A very useful piece of the puzzle in determining a structural formula for a compound would be being able to determine how many double bond equivalents, or in our case we're going to call it index of hydrogen deficiency, might be present in a molecule. So for every 2 hydrogen atoms fewer than in an alkane with the same number of carbons, there's 1 double bond or ring present. So you can consider my example here, C4H10 versus C4H8. So C4H10 would be the parent alkane, all right, that has the standard general formula of an alkane. It would have 10 hydrogens. Now, if we were to present you with C4H8, we would say, okay, well, there are 2 fewer hydrogens than present in C4H10. So we'll go up here and we'll just sew this all together. For every 2 hydrogen atoms fewer, so there's 2 fewer here. All right, there's 1 double bond or ring present. All right, this is what's known as a double bond equivalent, sometimes abbreviated DBE. So this means that C4H8 has either a double bond or a ring present. All right, let's check by drawing a couple sample structures. So I'll put 4 carbons in a row, put a double bond here. I'm just going to need to make sure I give every carbon 4 bonds. Every carbon has 4 bonds. There's 4 carbons, 8 hydrogens. There's a double bond clearly shown there. The index of hydrogen deficiency in this molecule would be 1. Right? I could also look at potentially a ring structure. So I could put the 4 carbons in a cyclic type environment. Right? Again, so long as each carbon has 4 bonds, right? Each hydrogen has 1. Say there's 4 carbons, 8 hydrogens. This molecule also has an index of hydrogen deficiency equal to 1. All right, so there's a few little tricks that need to be applied as well, though. Of course there are. You need to treat a halogen as if it was a hydrogen when doing this calculation, and it's strictly for this calculation. Every time a nitrogen is present, you need to subtract 1 hydrogen from the total before calculating. So let's look at the halogen example first. So C4H8Cl2, if the halogen is treated as a hydrogen, would be written as C4H10, 8 from the 8 plus 2, 8 hydrogens, 2 chlorines, equals 10. So the index of hydrogen deficiency for that guy is 0. All right, another example here, we'll treat a nitrogen. We'll say this CH3, CH2, C triple bond N. You can see that it would have 3 carbons, 5 hydrogen, and a nitrogen in there. So I need to, before I go and calculate the IHD number for this, I need to subtract 1 hydrogen from the total. All right, so we'll say 5 minus 1 is 4. So I'm going to need to write sort of a modified formula here as C3H4. All right, and then now what I'll do is I'll go and I will write what the ideal parent alkane would be here. It would be C3H8, following the 2n plus 2 rule for an alkane. So there are 4 fewer hydrogens in C3H4. Remember that for every 2 hydrogens, there was 1 double bond equivalent. So in this case, there's 4 fewer, so that means it has an index of hydrogen deficiency of